In the heart of a major global city, a commercial building made an autonomous decision at 3 a.m. analyzing reservation data. It detected a surge of conference room bookings scheduled for 10 the following morning and proactively moved up the cooling cycle by 2 full hours. No facility manager issued the order. An AI made the call. The result: electricity costs dropped by 17%, and tenant satisfaction scores climbed. This is not a vision of the distant future. It is happening right now, in smart buildings across the world. So what does this shift mean for architects and interior designers? Today, we are going to dig deep into the intersection of AI and smart buildings and explore exactly what you need to prepare. Buildings account for approximately 40% of global energy consumption, making them the single largest energy-using sector on the planet. Across developed economies, the built environment is responsible for roughly 28 to 40% of total carbon emissions, depending on the region and energy grid. The regulatory pressure to change this is intensifying and accelerating. The European Union's Green Deal mandates near-zero energy performance standards for all new buildings by 2030. In the United States, ASHRAE 90.1 updates are progressively tightening minimum energy efficiency requirements. Across Southeast Asia, the Middle East, and beyond, governments are moving in a single direction: stricter standards, faster timelines, and mandatory compliance. Yet the way most buildings are actually managed today has barely changed. Facility teams still rely on fixed timer schedules and manual HVAC adjustments. Industry analysts estimate that up to 30% of energy consumed in commercial buildings is simply wasted through overconditioning empty spaces, equipment running on outdated schedules, and reactive rather than predictive maintenance. This is precisely the 30% that AI is targeting, and the market has taken clear notice. The global smart building market was valued at approximately $100 billion in 2024 and is projected to reach $328 billion by 2030. For architecture and design professionals who ignore this trend, falling behind in client conversations is only a matter of time. Let us take a closer look at what AI is concretely doing inside buildings today across 3 distinct capability domains. First, predictive energy control. AI simultaneously processes weather forecasts, real-time occupancy data, and historical energy consumption patterns to optimize heating, cooling, lighting, and ventilation at the minute level. This is not simple time-based scheduling, it is continuous, prediction-driven optimization that learns from every cycle and continuously adapts. Second, predictive equipment maintenance. AI monitors real-time sensor streams from chillers, air handling units, and elevators, analyzing vibration signatures, acoustic data, and electrical current draw. When anomalies are detected, the system issues advance warnings 2 to 4 weeks before a failure occurs. This eliminates costly unplanned downtime and the emergency repair expenses that follow. Third, space utilization optimization. AI connected to occupancy sensors learns the actual usage patterns of every zone in a building and automatically diverts energy away from underused spaces. Advanced systems are now beginning to generate proactive recommendations for space reconfiguration, shifting from reactive facility management to forward-looking strategic insight. When all 3 capabilities are integrated, field data consistently shows annual building operating cost reductions in the range of 20 to 40%. That is not a marginal improvement. That is a fundamental transformation in building economics. Here is the critical insight that most design professionals still miss. AI is not something you bolt on after a building is complete. To fully maximize its effectiveness, AI infrastructure must be embedded from the very first stages of design. So what does that actually look like in practice for architects and interior designers? There are 4 core actions. First, plan your sensor infrastructure at the structural drawing stage. IoT sensor placement and quantities need to be confirmed while the building's structural layout is still being developed, not after walls are closed. Retrofitting conduit and cabling after construction typically costs 3 times more than planning it from the outset. Second, specify interoperable building automation and energy management systems from the start. Your building automation system and energy management system must be designed to communicate with AI platforms using open, standardized protocols. BACnet and MQTT are the foundational standards. Locking these in early eliminates costly integration failures later in the project. Third, design your BIM model as a digital twin data layer from day one. BIM is no longer just a 3D design and documentation tool. It must be constructed from the very beginning as the operational foundation that AI systems will read and interact with throughout the building's entire lifespan, with accurate spatial attributes, equipment specifications, and energy zone definitions embedded directly into the model. Fourth, make the ROI case clearly for your clients. Smart infrastructure typically adds 8 to 15% to upfront project costs, but the investment is recovered within 7 to 10 years through compounding energy and operational savings. Presenting this evidence-based financial case in your proposals is one of the most effective ways to differentiate your practice and win competitive bids. Let us move from theory to real-world evidence. The most widely cited case remains Google's application of DeepMind AI to the cooling systems across its data centers and campus facilities, reducing cooling energy consumption by 40% almost immediately after deployment. In Singapore, Marina One, a landmark mixed-use development, implemented AI-based building energy management and achieved a 35% reduction in carbon emissions, earning the Green Mark Platinum certification. In Amsterdam, The Edge, a commercial office building developed by OVG Real Estate, is widely regarded as one of the most AI-integrated smart buildings in the world. Powered by a dense, Ethernet-connected sensor network and a sophisticated AI optimization platform, it achieved an exceptional BREEAM sustainability rating and dramatically reduced energy use per occupant. What is particularly compelling for designers and architects is the rapid global rise of AI retrofitting, layering smart sensors and AI software onto existing building systems without major structural intervention, lifting energy performance by 20 to 30%. This approach is gaining fast traction across commercial real estate portfolios worldwide, and it represents a meaningful opportunity for interior designers to bundle AI retrofit services into renovation proposals as a clear market differentiator. So what can working architects and interior designers actually do, starting right now, to position themselves at the forefront of this shift? Here are 3 concrete, immediately actionable steps. First, learn the leading AI energy management platforms. On the global market, Siemens Desigo CC, Johnson Controls OpenBlue, Honeywell Forge, and Schneider Electric EcoStruxure are the dominant enterprise-grade building energy management platforms. Understanding their design requirements and integration specifications, even at a high level, will fundamentally sharpen the conversations you have with mechanical engineers, electrical engineers, and technology consultants. Your vocabulary, your questions, and your project briefs will all become more precise and credible. Second, upgrade your BIM practice to digital twin standard. This means going well beyond 3D geometry and visual documentation. It means systematically embedding precise spatial attribute data, equipment specifications, energy zone boundaries, and system connectivity information directly into your BIM models, so they are AI-readable and operationally useful from the moment a building opens. This is not a future-facing option. It will rapidly become the baseline expectation from sophisticated clients. Third, make energy simulation a non-negotiable part of every proposal. Tools like Autodesk Insight and IDA ICE allow you to model and predict building energy performance from the earliest design stages, including simulation results in your client presentations, showing projected energy use intensity, carbon impact, and long-term cost savings. Builds a level of technical credibility that clearly sets leading design practices apart from the competition. Let us bring it all together. AI is now functioning as the cognitive layer of the built environment, predicting energy demand before it peaks, preventing equipment failure before it happens, and continuously optimizing space for the people inside. This is not simply an information technology trend layered on top of architecture. It is a fundamental paradigm shift in how we conceive of, design, and operate buildings over their entire lifespan. Globally, the trajectory is unmistakable. The International Energy Agency's Net Zero by 2050 roadmap calls for all new buildings to be zero carbon ready by 2030, and for existing building stock to be retrofitted at an unprecedented scale in the years that follow. Client expectations are rising in parallel. Architects and interior designers are now expected to command AI as a core design language to understand not only how a building looks and how it feels to inhabit, but how intelligently and efficiently it governs itself. The buildings we design will be evaluated not just on their aesthetic ambition and spatial generosity, but on how autonomously and efficiently they manage their own operations over decades. For every design professional watching this, the question is no longer whether to engage with this shift. The only question is how quickly you begin.